This is the Aftermarket Radio Network.
Hey there, it's Matt Bonslow with Diagnosing the Aftermarket A to Z on the Aftermarket Radio Network. Today, I'm thrilled to have a guest, a good friend of mine, Sean Tipping, who is an instructor for a college, and B, a mobile diagnostic tech. So I've asked Sean to join me because I hate talking to myself and I needed somebody to banter with, but I kind of have a vehicle I want to discuss and a piece of equipment I used, and I really wanted Sean's input as an instructor and also as a mobile tech. So very much looking forward to this. Thank you, Sean, for joining me.
Of course, I am. I'm super excited to be here, Matt. I think it's really cool that you got your own show now. This is I'm pumped for this. I want to I'm excited to listen to your episodes for this show.
I didn't purposely ignore the fact that you have the Automotive Diagnostic podcast, but I wanted it to lead into this. This worked out fairly well for me that I've been on yours and Carm's shows so often that the powers that be just decided, hey, you know what? You should just have your own show. You know what? Make room for the rest of us.
Yeah.
Very glad you could join me so soon and on fairly short notice.
Well, that's how it works in the podcasting world. It's usually hey, what are you doing tonight? You got time for a 2-hour podcast? And somehow people in the automotive industry seem to make that time work.
Yeah, and you just crossed 100 episodes. You're up to, 101? At least that are out in the out and available, 101. You might have far more.
I got a couple in the memory banks waiting to come out, but yeah, it's been fantastic ride so far. That's all I can say. Honestly, you're probably the single biggest contributor to the show. I know for a fact you've been on more episodes than anybody else. So big thank you to you. But just everybody that I've gotten to talk to. I think I've mentioned this before, but I wouldn't necessarily, me personally, have an excuse to sit down and have long conversations about this stuff with these particular people. I'm just not that guy to call somebody up, be like, hey, you want to talk about the automotive industry? But it gives me a reason to, and other people like to listen to it, which is cool. But honestly, I've enjoyed it so much just getting to chat with everybody. So I feel lucky to be able to do it and lucky to be here with chatting with you right now.
It's a really good one, especially the ones without me. Those are some of the best ones. You've been a college instructor now for a while, right?
Yeah.
College or technical college or?
Yeah, it's a community college. They have academic courses and then a bunch of trades as well. And this is my fifth year, or my fifth group of students. So we're about halfway through the fall semester right now. And, COVID obviously threw a wrench in the works there for a little while, but I'm definitely getting my feet under me as far as this goes, because I had no previous teaching experience before I started teaching in 2017. And so it's been, that has been another big learning experience for me. But I am feeling much more comfortable each year that I do it. So I enjoy it quite a bit too.
What made you decide to start doing mobile stuff?
I'm a glutton for punishment, number one. I finished my first year of teaching, which was brutal because I had to go in, write 10 courses from scratch because the previous guy took all his material, which after I wrote 10, I understood why he took it. It was his, he created it. But God, I feel guilty if I had somebody replace me and I just took everything and didn't help them at all. Yeah, that's the way it worked. And so the first year was brutal. And so I was like, oh, summertime, awesome. I'm just going to relax all summer and have a great time and hang out with my friends and do whatever. It's awesome in Minnesota in the summer. And I did that for about 2 weeks. I was just a lazy bum and just sat around the house and really didn't do a whole lot of anything, honestly. And then I was bored. I was like, I need something to do. And see all these other mobile guys doing their thing, just out there being really impressive, to me anyways. And I'm like, okay, well, let me look into this. And that first summer, I just slowly started. It was very, very minimal at first, maybe a job a week where I'd go program a GM control module or something. And kind of just snowballed from there because I got a taste for it. I enjoyed it. It was a good challenge. And then I also realized, oh, this is keeping me up on stuff. But now that I'm not an actual technician anymore, I'm not wrenching every day like I was when I was at Firestone, and you kind of get rusty. And I was like, well, this will help me keep up on everything for my classes, stay relevant for my students, which I value when I have a relevant instructor. So I want to be the same for them. And it's continued to grow, almost at a rate that I can't control, but there's worse problems out there. So
yeah, definitely.
Say no or raise my rates. I don't know. That's my solution to the overload of work that I have at the moment.
In the name of education can't be what you charge people.
Right.
I mean, you could.
There's certain vehicles that are good educators, and it's worth the time invested. But yeah, you don't want to do that every day.
I know we were going to Thornton classes. We were in the same classes often.
Yeah.
And I think I recognized your name through social media. I don't know if you had the podcast yet.
I didn't. No, I didn't start it until I had like 3 or 4 episodes out before COVID hit. And then you don't see anybody in person. And I don't think John has done his in-person classes up here since. But yeah, I think I sat next to you in one of the classes, and same thing. I recognize your name.
Sat next to me. Usually I think you sat like one row behind me to my right. Usually.
Yeah.
So anyways, I was going to tell you about this car I had. Maybe I should start out with almost I'm going to come clean. I broke down and used an Ohmmeter, and I don't know, maybe you'll kind of laugh at that, or maybe you'll wonder, like, what am I talking about? But I got to level with you. I never used my Ohmmeter ever. It was taught, I guess, out of me.
Mm-hmm.
In school, not my 2-year, but my 3rd year of automotive. It was a program, automotive diagnostic program at Alexandria, which I don't know if people even know much about that anymore. I don't know if you guys, as like community college, have ever heard of that or heard about the program, but it was a 3rd year program, and they literally reprimanded you for using your Ohmmeter, except in like very, very specific purposes. You better not be checking the resistance of a GM Multec fuel injector. Don't do it. We either have a tool for that or you scope it.
Mm-hmm.
I don't use it. I never use it. So I got this 2014 Chevy Silverado towed to me from another repair shop. And turns out this thing has had quite the journey. It started out, I think, in Massachusetts.
Okay.
And not at Joel Amaril's shop. It was a Chevy dealer, and the client had it towed there, and it was a no crank, no start, and it sounds like they gave up on it. And that's not to trash the dealership. This thing was a mess. The dealership called it a lightning strike. Customer reached out to their insurance company. They totaled it immediately. It went off to the evidently either a salvage yard and somebody bought it back, or the dealership ran it on the auction, a dealer auction. And it made its way to, it sounds like, South Dakota, where this shop bought it. And it's a shop from, I think, Wisconsin. Could have been Minnesota. Doesn't really matter, really. But anyways, they buy it. I guess they get a smoking deal on it. And this truck is immaculate. It's immaculate. I think it was maybe 60,000 miles, no rust, nothing. It looked like brand new inside and out. It was I'm not like the pickup guy who just gushes over vehicles, but in their defense, it sounds like they bought it very, very inexpensively, and it was a beautiful vehicle.
Okay.
They confront the no crank, no start, and they figure out that the truck, if you will, the quote unquote, the truck, doesn't recognize the key.
Okay.
they start out, I think they put a body control module in it. Then they put the transceiver in it, or the halo or theft module, if you will, around the key.
Sure.
And then they put a powertrain control module on it. And they had the ability to program these things, and they programmed.
Okay.
Same issue. Threw their hands up, and then somehow, some way, they find me, know about me. I don't know. Call me up. Do you want to take a crack at this? And I'm like intrigued, like no crank, no start. How big a deal can that be? And
Right.
not even like condescending, is really just curiosity. Like what?
Right.
It's got to be a network problem.
Uh-huh.
So it shows up. I can communicate with a lot of modules, but not all of them. It's almost like, I don't know, maybe describe it as a shotgun splatter pattern about what you can communicate with and what you can't.
Okay. Is this like a fully loaded pickup truck with a lot of modules, or is it like a work truck with like 5 or 6?
On the outside, it looks like a work truck, but on the inside, I mean, I have a most network. I have LIN bus. I have CAN high,
Gotcha.
or GM high speed LAN, if you will. A couple different CAN buses. So I can talk to some modules, and others I can't. So offhand, off the top of my head, ABS control module I can't talk to.
Okay.
Fuel pump control. Well, wait, fuel pump control module is not. That had a network to it, but it wasn't where you talk to it directly. So anyways, it doesn't see the key. The theft light comes on, doesn't go out, flashes, all that. I try programming that thing. I had all my key programming tools on it. I had factory scan tool on it. I mean, I was killing myself. I mean, factory scan tool, I guess, in this case is SPS.
Could you talk to the theft deterrent module?
Oh, yeah.
Okay.
Yeah, I could look at the data.
Yeah.
Lots of codes, communication codes. It didn't have the like start blocked by theft in the PCM or anything like that.
Okay.
So it was just weird. So, okay, I'm thinking it's got to be network. So what do? Bust out my DLC breakout box and the line spy, and then I plug in my Pico. And I'm telling you, the CAN bus is a mess.
Okay.
It was a mess. So then what do you do with that? Most networks that I dealt with, network issues, I could scope the CAN bus and generally get away with unplugging modules or finding some sort of maybe like a splice pack, maybe like some sort of a central, for lack of I don't think they're technically called splice packs on CAN, but if there were as a splice pack or a joint connector somewhere, some way where I could start
dividing the network.
Yeah. This was not laid out that way. You could not just unplug modules. I mean, you could, it just wasn't going to help you.
Okay.
Yeah. The CAN GM LAN went into the module and it came out of the module.
Yeah.
So if you wanted to do that, you were using jumpers. You had to jumper wire across to quote unquote bypass it, almost like the MOST bus.
Sure.
The GM MOST bus. So if you're a Euro guy, different kind of a MOST.
But I mean, that's what you do with those too. You loop it if you want to bypass the module on those. So yeah, kind of the same idea with the GM LAN.
So I'm kind of banging my head against the wall, and I call Thornton on an completely unrelated.
Mm-hmm.
And we're just shooting the breeze. And then he's like, well, you got anything interesting going on in the shop? I'm like, as a matter of fact, I do. And I was kind of telling him about it, like, and doing this with a math channel, comparing the low to high. And it's like, I think it's really more on the low, it's can low. And he's like, well, what's the resistance? What do you mean that the resistance is? I got my scope on it,
Mm-hmm.
And he's like, you might find that helpful. So that's really all we talked about. It is just this really kind of cool car, or issue, I should say. And so I bust out the ohmmeter and I plug it in, and I have like 86 ohms at the DLC.
Okay.
And this is where things get for me, this is where things kind of go really interesting. Is now, because I have the ohmmeter on there, I can kind of divide this vehicle in half.
Sure.
Where the DLC goes and how it loops through everything. You know, the first thing it hits, I think, was like the transfer case control module, which A, you couldn't communicate with, and B, when you plugged it in, would blow the 40 amp fuse immediately. I mean, it would explode. So, but anyways, I go and I find a connector under the hood on the driver's side, very close to the firewall, and kind of part of, or connected to, stuck to, if you will, the power distribution center area. And I find the CAN wires and I cut them because I want to kind of start dividing this problem up.
Yeah.
And I cut the wires and it goes open loop. OL.
Okay.
Out of limits. Open loop. Jeez. It was running and I cut the wires and it went open loop. It was not running, but I cut those wires. It goes out of limits and, super high resistance.
So you're measuring from what point when you did that? When
I was at the DLC.
Okay.
Yep, I was at the DLC.
Gotcha.
And I mean, without a diagram, you should probably email everybody diagrams so we can follow along. And I know I'm trying to talk about this, with no visual references. But I don't know that it's all that important because, you have the wiring schematic in your hand, and it didn't matter if it was the OE one or the Valley Forge styles that you would get in Mitchell or Aldat, or now Identifix has them as well. The color diagrams. Mm-hmm. The pathing seemed accurate, but it should have been where I cut them. I should have been able to measure the resistor, the terminating resistor in the back of the vehicle, which would have been by the fuel pump control module. Okay. And is open circuited. Okay. And that's where I needed two. I had two of the AES Wave U-tests kits. Those came in very, very handy on this vehicle. Okay. Because I had to break down and start jumping stuff. And I'm just going to say, it's not a long story, but I got to the ABS control module, and that was open. Not just open on one, but open on both CAN high and CAN low, and open internally. Weird. And this was a hint as where this vehicle was going to go. Because when I jumped that, I got some, I got like 100 and, I don't know, it was like 150 ohms of resistance. So, I mean, just long story short, what ends up happening is I have a series of modules that are failed internally, affecting the network in different ways. Okay. And so some were open, just blatantly open. Some of them were partially shorted. So like the HMI module, CAN high and CAN low were resistively shorted internally. This was just a mind job. And it's you start questioning every test because no way, just no way. And the only explanation I have is this thing's a lightning strike. I don't know what else would cause this. And it's not limited to just these module failures on the network. The fuel pump control module didn't work. And it wasn't a Dorman. It was the OE one. Okay. No fuel pressure. So, I got communication going. I got a key programmed. It would crank over, not start. I had no fuel pressure. Fuel pump wasn't being commanded on. So fuel pump control module. Replace the transfer case control module. No communication. Not adversely affecting the network, but it just won't talk, and internally shorted. I assumed when I plugged it in and the 40 amp blew that I had an issue with like the transfer case shift motor. Yeah. I just assumed that, and I didn't replace it, but that was where my line of thinking was. Unplugged the motor, still blew the fuse. Okay. And then I, get a big headlight in there. Actually, it was two headlights in a row and in series to try to get that current flow up. And man, every time I plugged it in, it popped. So it got a transfer case control module. Okay. And that fixed that. Then the odd thing is we're replacing all these modules. And I think all in all, I'm just on CAN type modules. I think I was up to about 8. Wow. Right.
Yeah.
So we got the transfer case control module. We got the HMI, fuel pump control module, power steering control module. What sucked to the power, I guess, not to be jumping around, but we would replace these modules, would gain communication with them.
Okay.
So a lot of these were, they were adversely affecting the CAN network, preventing me from doing certain things or communicating with certain modules. The other thing is some of them were dead to the world. In this case, the power steering control module was not adversely affecting the CAN network, but it wouldn't talk.
Okay.
We replaced the power steering control module, and then lo and behold, it sets a steering angle sensor code and torque sensor code. Torque sensor code is part of the rack. Guess what you get when you order a rack? A new power steering control module.
Of course.
Yeah, that was awesome. So that's just the CAN network, and it wasn't limited to just that. The PCM, when I could talk to that and only set like a single code or two, mass airflow sensor. Or on this one, it's, they call it the weather station. It's a whole bunch of stuff in that. But mass airflow, legitimately bad. Yeah, the sensor legitimately is bad. It's not wiring. It's not terminal tension. The sensor is bad. The steering angle sensor was legitimately bad. The torque sensor, legitimately bad. And it just doesn't stop. The ABS control module, put that in. It sets codes for the vacuum sensor at the brake booster. This went on and on and on. And the owner of the truck is the coolest person I've ever met.
I was going to ask, how do you proceed with buying parts for this?
This thing's going insane. And he's like, you're the guy. If it's broke, fix it.
Okay.
You start thinking about just ordering everything.
Right.
But it didn't need everything. And that was just the CAN. Now, another complaint. The power windows don't work and the battery goes dead.
Jeez.
Right? Turns out it needs the driver's door module and it needs the master switch. So when I diagnosed the bad master switch, I plugged it in and it didn't work. Like very little changed other than the output of the switch.
Yeah.
And I'm like, you idiot, you misdiagnosed this. You got lazy. Needed the driver's door module, which is part of the window motor. Okay, put that in.
Mm-hmm.
The windows, the front two windows work.
Okay.
The driver's and passenger front windows work. The rear ones don't. So I'm like, yeah, you suck. Now you're going to plug in the old switch and it'll work. No, it didn't. So it needed both.
Jeez.
And then you go to the back and those were a little more, those weren't door modules in there. They're just straight up, but needed both switches. Passenger and driver's rear window switches.
Those got boards in them. I mean, it's more than just a switch, right?
Not much more.
Okay.
That was pretty simple.
Okay.
But it's like, what in the heck happened to this truck? And you're asking them you asked, did you hook the battery up backwards? But man, if people hook up batteries backwards, usually there's signs.
Sure.
And why the CAN network on some of these modules, like they're internally open or partially shorted.
The ABS to open up on both of those basically shorting bars for the network inside. That's nuts.
It was the most insane thing. I don't know. I spent a lot of time at the shop. It became kind of a, part of the shop.
Yeah.
And to, put like flowers in it and stuff. dress up the place. But it's just like one thing after the other and then waiting for parts. And some of them you could get rather quickly and some of them not so quickly. And man, it was just the most insane thing. But yeah, it was the Ohmmeter. Because the scope, you would have been jumping a lot of stuff except for, probably the PCM would have been the only thing you wouldn't have really been able to disconnect.
Is that at the end of the network on that one?
Yeah, the PCM's on the one end with a terminating resistor, and then the terminating resistor is in its own connector, if you will.
Sure.
Back by the fuel pump control module taped to the frame. And I measured the resistance of both of them because this just seems so weird. But they were fine.
Okay.
The BCM probably would have had to been on there too, just even for power moding and stuff.
Mm-hmm.
Wake up. Or I would have had to, manually wake everything up.
Right.
So yeah, I've been in classes, or I've presented classes where I've been pretty anti-ohmmeter, because I would say my mantra would be, and really stolen from Harvey Chan, is the thing with an ohmmeter is if you test it and it tests bad, it's bad. But if you test it and it's good, it might still be bad.
Right.
And I was showing a coworker this because I was seeing he was using his ohmmeter a lot, and I was just busting his balls pretty hard about it. And I took a voltmeter with his ohmmeter and showed him, like, your ohmmeter puts out like 3 volts.
Okay.
There's no load. And then I reversed it and showed him, like, I think I was showing him like a Vantage Pro that put out what I felt was a fairly impressive 5 volts.
Okay.
So there's no circuit loading involved.
Right.
That's why I'm pretty anti-ohmmeter. I know a lot of car manufacturers, at least in the past, that was a very important test, was cavity to cavity, terminal to terminal, using an ohmmeter to verify circuit integrity. And it's a weak test. It's extremely weak.
You see it in flowcharts all the time for when you look at the DTC stuff. I know Chrysler and Ford, they'll have you ohm checking all kinds of things. So that's like probably the number one test that you do when you go through the flowcharts on those is, let's ohm it to ground, ohm it to this wire, ohm it to that wire. It's just all over the place. And you're going to spend a lot of time if you follow every one of those steps in the flowchart with the ohm checks.
Yep. Yeah. So, but I guess in the case of the network, we do know that we have 2 120 ohm terminating resistors, at least in the CAN network, this particular one, or most. And you would expect 60 ohms. And when they're on, it's close. Trying to think, like, again, I don't measure the resistance of a lot of networks, but I don't really remember many dropping much below 57.8, 57, 58.
Maybe up to 62.
Remember. Yeah. I mean, when they're on, they're usually pretty on. So it's not a horrible test, but to me, what gave it, and granted, this is kind of a jacked up vehicle. What gave it that testing relativity, or relevance, I guess would be an even better word, is the ability to split the vehicle and get a direction. In my case, it was both directions. It was going both ways. But generally, that's not the case. This is not going to be the regular issue.
Yeah, these GM networks where they're I call it daisy chained, and I think I might have heard that from somebody else, but that's the term I use for those, where it goes, it's like an in and out of the module. And I realize the CAN network's not in and out, but that's what I consider it. Like, I started the DLC and I work away from that, and so I consider something farther away from me downstream, right? Like the PCM or the ECM is the farthest downstream because it's at the end. There's only 2 CAN wires going to it, right? And I don't know of another manufacturer that does that on a regular basis, but GM has obviously been pretty in love with that model. And of course, we see a lot of GMs, we see a lot of issues with that too, because let's say on a Chrysler, you have an ABS module that for some reason becomes unplugged or disconnected. That's not going to disable a vehicle. That's just going to disable the ABS and set some codes and some lights and stuff. But you have a Chevy truck where that ABS module comes disconnected and you got the fuel pump module downstream from that. Your vehicle's not running anymore. And there's a ton of different scenarios because there's so many different network configurations. But it builds in a more likelihood for failures that disable the vehicle or cause major vehicle-wide problems that you wouldn't see in others, because it's just, you open up that network in one spot, and I realize it can happen on other vehicles too, but you open it up at a connector, at a module or whatever, and that's it. It's down. And yeah, so I don't know, I seem to get calls for these. Maybe it's just the GMs are more common, but boy, I see a lot of problems with those networks. And yeah, that's where that ohm meter. Okay, so here's the deal. I'm actually kind of a proponent of the ohm meter. I understand the whole loading the circuit thing. I totally 100% do. And that's part of it. That's part of why I suggested in certain places you have to know where it can do something for you, what its limitations are. And that's one of the things I talk to my students about. It's like any test that you do, you got to know the limitations. There's a purpose for it and it can do something for you, but you have to ask yourself, okay, if this passes the test that I'm doing with this, like you said, or you were talking, Harvey Chan said, like, if it fails, it's failed, but if it's good, does that mean it's good? It's like, that blue block tester fluid that you use for head gaskets, right? If that fails, if it turns yellow, you definitely have a problem. But if it doesn't change color, that doesn't mean that you don't have a problem, right? Same thing.
That's a very, very good comparison. You're spot on.
Yeah, and does that mean you should never use it? Not necessarily. Are there other methods that maybe are more effective? Yeah, probably, but it could still potentially be something that you could use in a situation and get an answer quickly. But the ohm meter, if you understand its limitations, I think it can still be useful. And that GM daisy chain style network is really one where this 2-wire circuit is running the length of the vehicle. And I don't know, if you stretch those wires out, you'd have 40 feet of wiring, right? And you can quickly touch 2 terminals underneath the steering wheel and assess that entire thing like that with a number. That's pretty powerful. That's a place where that can really be useful. But yes, understand that you're not loading that circuit. Don't use that on a wire to a headlight that's not brightly lit. Like that's probably not going to be the effective place for it. You have to understand what that tool is doing, what the limitations are for that testing method. So I don't know. Yeah, I use my ohm meter all the time. Here's the other time that I use my ohm meter is just for verifying that I'm on the right pin for something. Like I'm looking at a connector. It's got a bunch of pins. I'll switch it to the continuity, the beep mode. And I just want to make sure, okay, beep. Okay, cool. I'm on the right circuit. This is the one that I want to be testing. I'll use it for that. It actually saved me, or it helped me diagnose. I go to a lot of transmission shops, right? And so they'll rebuild transmissions and they'll replace the sub harness. And so that's like the connector on the outside of the transmission, down inside under the pan, to all the solenoids and the sensors. And a transmission shop did this on a Dodge, and they had a pressure sensor code that kept setting. And they replaced the pressure sensor, and they traced all the wiring, and they couldn't figure out what was going on. And it ended up being that the connector at the pressure sensor, 2 wires were in the wrong position. They were basically swapped from where they were supposed to be. Right. And I got them drop the pan, and I'm doing some testing. I'm like, something doesn't make sense here. So I get up to the connector on the outside of the transmission, and I have my wire down on my suspect circuit, and I set my ohm meter to beep at me, and I'm just quickly touching the terminals until it beeps. I look at the number. I'm like, okay, well, this is the wrong one. Right. Could you do that with another method? 100%. But I couldn't see where the wires went into the back of this connector. I could only see the front side, so I couldn't tell the colors and where they were arranged. The Ohmmeter made quick work of it for me, right? Only because I understand what it's doing. I understand the tool and what it can do for me, but you also have to understand what it can't do for you. If you don't have that, if you think it can just give you the answer every time, then right. I think that's where the instructors are probably coming from at your school, was that if you rely on this thing as an end-all be-all circuit analysis, then yeah, you're going to make wrong calls, or maybe waste time like the flow charts tell you. But if you get what it does and what it does well, I don't see why you can't use it.
I mean, we're talking late 90s. So, man, what do we have for networks? UART.
Right.
Chrysler had the CCD bus. I mean, I guess maybe as some SCP, maybe a little bit. And I would say in the independent world, in the independent shop, at the dealer level, okay, they were seeing for sure probably SCP, CCD. I don't know if they would have been seeing the next level of Chrysler. It's very, very like class 2. I forgot the name of it though.
There's a SPI, is that it? I just remember the no bus light on the dashboard. Oh, those are still there on some of them.
PCI. It's PCI bus. Oh,
okay.
Man, it was right there. PCI bus. They're probably starting to see that, or almost assuredly seeing that. And their point was on most of the drivability type stuff and electrical. So lighting, that was their big thing. Minnesota, a lot of corrosion, corroded connectors, rock chips. So like rocks would get kicked up under the vehicle, hit a harness, cut the wire, or at least cut the insulation, and they would corrode inside. And we got that pixie sticks scenario where I still urge everyone, do not taste it. It's not lime. What would happen is the Ohmmeter would pass with flying colors. It was very low resistance. Technicians would not be able to figure out what's wrong with the vehicle or what's causing this issue. Spending way longer to figure it out than they should. And then the voltage drop, of course, would be the dead giveaway, or using a test light, a higher load test light, something. I've been buying some test lights from Harbor Freight for, I don't know if they're even $5, $4. They got an incandescent bulb in them, or as I'm sure you do, you start building your own arsenal, if you will.
Right.
Varying sizes of bulbs. So, 194s, 31, 1156s, 3156s, something of that nature, and then sealed beam headlight.
I can say this: if you stick a 1 amp bulb that fits in your test light, it'll work, but it'll melt the plastic of the test light eventually. So just a warning to anybody out there that wants to mess around with their own tools.
I can just see it just melts. You're holding it and your hands on fire.
It did work for a while, but I kind of noticed like, it's getting a little distorted. And the more and more I used it, it would sort of just melt more and more. I'm like, okay.
I've long said that you can kind of judge a tech's electrical ability, testability. If you look in their toolbox and, if they've got a meter and a scope, that's good. But if you open up that toolbox and they have an array of bulbs with little pigtails, they probably know their stuff.
Mm-hmm. Yep. Okay, let me ask you something here. I'm thinking about talking to students about, what we're referring to as far as you got to check the circuit loaded, right? And we say that a lot and use voltage drop, and they get that. And a lot of them will just use voltage drop and they don't even really grasp why they're doing it, right? And then, some students will be using voltage drop on a circuit that has no current flow through it. And then it's really a useless test, right? And then it really throws them for a loop. Yeah. Or they're going voltage drop across an open load and it's showing 12 volts across that, right? But they don't understand, right? So anyways, and maybe I'm getting away from my question here. Explaining how an ohmmeter will measure, let's say you got a wire, it's got green crusties in the middle, right? You ohm it, it measures 0 ohms, which you would expect from a wire, right? But if you try to put a few amps of current through that, it's not going to happen. And I've kind of struggled with, and I show them examples and we talk about it, but I've kind of struggled with a real simple way to explain how it doesn't measure as resistance with an ohmmeter, but there is resistance there if you try to force a load through it. Do you have like a you have an explanation for that? A simple way to put that to somebody that would kind of click with maybe some beginners.
I mean, I hate water analogies. It's probably stupid of me to hate it because a lot of electrical problems have been fixed due to people thinking of electricity as water.
Okay.
And water flow. In this case, you're talking about the ohmmeter is just trickling water through. There's no current. Voltage is really low. Current is even less.
Uh-huh.
So there's the one little strand of wire, even if it's not all that, the integrity is not that great, still will allow that little bit of water through. It's almost like a really rickety bridge.
Mm-hmm.
Your kid could walk across it, be just fine.
Sure.
You walk across it and you're swimming.
Yeah.
Assuming it's over a river. And if it's over just a canyon, you're dead. Or I guess depending on how high the bridge is. Okay, this is going sideways, but we're getting off the rails. That would be the way I would start thinking of it. Either the water or even the bridge. Like you're talking about load, and the ohmmeter just doesn't put any kind of a load on the circuit. It's very, very little. At least the digital, DMMs or DVOMs that we use.
Yeah.
Some of them older analog ohmmeters, I think they put a little bit of more load on there. I don't want to imply they're putting like an amp on it.
Sure.
If somebody wanted to build a tool, that would probably be pretty cool, is an ohmmeter that you could kind of adjust how much current, and it would actually apply 12 volts. And now you're looking at, more of a dynamic resistance, which, we calculate that way by looking at voltage and current.
Right.
And I guess that's kind of where that goes too, is the demonstration. The one way to think about it would be the bridge, the bridge scenario. The other way is showing, like something visual with the Ohm's law. Set the voltage at whatever the meter puts out, 5 volts. Well, the current's going to be extremely low. You can kind of do whatever you want with the resistance. It's not going to really affect them.
Right.
But you start adding some current and, probably some voltage too. All of a sudden, now that change in resistance affects current. And I mean, depending on where we're measuring the voltage would affect the voltage as well, right? The voltage drop. You'd be dropping voltage across this load. This resistance becomes a load. Not to go too crazy with this, but
no, that's a good way. I definitely have never thought of pointing out the voltage that the meter puts out. I've never mentioned that in class, so that's a good just point to show everybody there. But it kind of makes sense then too. If you're looking at it, you start bringing the mathematical portion into it, right? Like you're saying, like amps and resistance, stuff like that. That definitely makes sense.
I wonder if you could find like an older analog meter, Facebook Marketplace or Craigslist or
sure. Might be buried at the school somewhere. There's some storage rooms there that there's some really especially old stuff. Like an
electronics course or something.
Mm-hmm.
The old analogs, I think, would put out a little bit more voltage, a little more current. Especially like, they're all battery powered, but I think they had a fairly good. They're heavy, and then took energy to really move that needle.
Okay.
Everything wasn't like super solid state, but I wonder if you could just find one of those, even if it wasn't perfect. And compare it, just measuring the resistance of like a bulb or something that requires some current flow to work.
Yeah.
And just measure the resistance. Not that measuring resistance of bulbs is ever a really good diagnostic test, but you're more after a concept that you measure the resistance of the bulb with this modern digital multimeter that puts out very low voltage, very low current. And now an old analog that puts a little bit out. Well, they're measuring different resistances. Which one's right? And you could argue they're both right, but they're both right and they're both wrong. Because now let's fire this thing up. Let's measure the current. Let's measure the voltage. Now, what's this dynamic resistance?
Sure.
on.
And that brings us back to what your instructors are telling you about is, let's look at the current when the circuit's operating, right? That's really telling us everything, especially when it's an output. And that's the other thing I try to get across to my students is like, you got to know what the circuit's purpose is, right? Is this an output or is this an input? Because it's going to change how I'm testing it, right? I'm not so concerned about load testing a map sensor signal wire, right? Maybe I need to do it in some weird scenario, but odds are probably not. But
very rare.
Injector or coil or some output that needs current, I'm going to think about that circuit differently and test it differently. And so, again, you should understand your testing equipment's limitations. You should have an expected result, but you should have a really good idea of what that circuit's purpose is, what that wire's purpose is before you start testing it. And I think that intuitively will guide you to using the right method or the right tool to assess it properly. But that's where all the learning and experience comes in, I think.
If they could leave, schooling with you guys with that, just kind of the fundamental understanding of it, I think that just puts them at a really good position for down the road. Especially, the best thing is learning something, be it in college or, at a class, a seminar, and then seeing it in front of you in the bay and having that light bulb go off in your head, just like, oh, that makes sense now. Now I get it. It just makes such perfect sense. And it's kind of it's a kind of a dichotomy, right? Between being really, really happy and being really upset with yourself.
Yeah. Like, how did I not get this before?
Yeah. Part of the reason I brought it up was to kind of ask how you handled that at the college level with students that, do you guys discuss the Ohmmeter and how prominent is it? And
yeah. So
you can't ignore it.
Right. It's right there on your, you click it over two things and you're there. But, so I don't do the basic electrical course, and I'm, good friends with the instructor that does. And his big thing is voltage drop, right? That's how we're testing circuits, and they cover the Ohmmeter. They know how to use it, but that's not what they're using, for circuit testing, which is awesome. Right. But going back to what I said, like, sometimes I'll get a student, and this isn't the fault of the instructor, right? It's just students are at various levels and they put various effort in to the course, and they'll do the voltage drop testing and they know how to perform it and they know how to, read the meter, but they don't necessarily understand why they're doing it in that situation or what's required to do that voltage drop test. And if they don't have that background, they don't have that understanding, the test throws them way off into left field. So it's tough to get everything packaged well for everybody. Teaching a whole group of students that are across a wide range of skill sets and effort and interest, that's way more difficult than I ever thought it would be. I thought everybody was going to show up for college and they were interested and they wanted to know this stuff and they're going to put effort in, and it's just plain and simple not true. And so you have to some people, you have to meet them at their level and do what you can for them at their level. And then the opposite's true for somebody at a higher level of effort or interest or skill, and try to meet them there and stretch yourself to meet both. It's definitely not a perfect science, and I definitely don't have it down, right? I've only been doing it for 5 years. So I'm barely scratching the surface, but I've been taken back at times by how much you need to, I don't want to say dumb down. That's a bad way to say it, but you have to bring stuff down for certain people in order for it to be useful for them. And then you have to bring it up for others, or they're going to be bored and they're not going to be interested. And then there'll be distracting other students. So you have to challenge them at the same time and do this all within the confines of accredited course that has specific outcomes. It's a challenge for sure.
I know we've talked in the past, I don't know that you guys have enough time,
Right.
to do a lot of it, because it's easy to say, like, specifically electricity. There's nothing that we interact with on a daily basis that acts like electricity. It's just kind of this phenomenon, and there's laws, if you will, that it follows, and we can use our benefit for checking for it and how it's behaving and all that. But also just a lot of auto repair in general, and I'm sure it goes through all sorts of other professions, but it just seems like ours is so varied, and the practical knowledge and experience of the entry level individual into these programs is it's lower than it's ever been before, because of the environments they're growing up in do not perpetuate any sort of mechanical aptitude at all.
Right.
Mom and dad or the neighbor or, grandpa, they're not fixing your bike anymore because they can't take it to the bike shop. It'll cost more for them to fix it than to buy you a new one. And mom and dad maybe don't know how to anymore. And the parts are probably more expensive than to just get you a new bike. So same with the lawnmower, right? You Google why the lawnmower doesn't start, put a spark plug in it and new gas and whatever. And if that doesn't fix it, you can't afford to fix it anymore. You can't take it anywhere and have somebody fix it. You just throw it in the dumpster and you go down to Walmart and buy a new one. And
yep.
So they're just never in a situation to learn how. I don't even know so much how things work. A lot of things, like a bike, you could see how that works.
Mm-hmm.
But if, one day the oven doesn't work and mom takes that all apart and finds, nowadays maybe a circuit board, but, a heating element, you may not know why the heating element works, but when you turn it on, it should glow red.
Mm-hmm.
And when there's a big missing gap in it, it ain't going to, it can't heat up anymore. So, you put the heating element in it and away it goes. I just don't think the vast majority of kids are subjected to any of that. The main thing that they deal with is really probably software, apps.
Mm-hmm.
Phone doesn't work, finally break down and do the master reboot, master reset, whatever. And then master reboot, that's a Toyota hybrid reference.
Yeah, they're great on technology. That's the thing. Is you get not the hardware level of things necessarily in the circuits and stuff, but the technology, the interface. That's where the students shine and beat me out most of the time on this stuff. So they do have an advantage there. But yeah, on the nuts and bolts of things, some are good. Some, especially where I'm at, we get some in from a rural area up north, and they've been experienced like when you were young and working on a farm and stuff like that. And they bring that, but that's not everybody. And for the ones that don't, I mean, is it more important for me to spend more time with them learning threaded fasteners and getting good at that to go into their entry level job than it is understanding networks and things like that? I mean, an argument could be made that I don't need to spend my time on networks and loading circuits and stuff. That they got to figure out how these nuts and bolts work so they can go make some money. So,
and they're probably not leaving a 2-year starting at a shop as the lead diagnostician.
Yeah, they might not touch a CAN network for several years after they go onto the field. Yeah.
But sometimes I wrestle with the idea, not wrestle like, this keeps me up at night, but the idea pops in my head if it was more like a mandatory 3 years, and then you get the kid in who grew up in a shop, however, is very mechanically inclined, can leapfrog to the second year. And now they're really going for 2 years, but some of these others, they're going to have a year of almost like generals, if you will. Not that they're going to be in all generals classes in the conventional sense, but in the automotive repair world, they're learning about this is a screwdriver, flathead, Phillips. This is a Torx.
Yep.
Male, female, or internal, external Torx. This is a hammer, and we find that silly. But there's so much of that. They just have no idea.
Mm-hmm.
I don't think it would be a waste of time at all to have something like that. And maybe it's not a whole year. Maybe it's, 3 months. I don't know. It would be interesting to play around with that. You start here, and they might learn so much from that. People that come and work for us, they've never heard of a mini ductor.
Sure. Right.
No concept of what that is, or what it does, or how it works.
Eat it.
Yeah. It's not a knock on them at all. It's, you don't know what you don't know, but you're coming into this profession and you don't have this, somebody tells you to go grab, even a Phillips screwdriver, as ridiculous as that may sound, or any number, a ball joint press, and you have no idea what that is. Mm-hmm. And if the box didn't say ball joint press on it, you wouldn't have grabbed it to bring it over. And the embarrassment of not knowing that, and here you go, like this, we're going to start you out at the very beginning, and I think that would be time very well spent. And then it would allow the more knowledgeable, the kids with the experience, not that there would be so many, but the program's already going, it's already there. They could leapfrog that.
Sure.
And now they're in year 2, which would be typically our year 1. And now they're in it. And it's just stuff I think about. And otherwise, it's usually when they start talking about a third year, the third year is more and more advanced. And whatever that means, usually involves diagnostics and scopes and maybe programming and stuff like that, where depending on where they're going to end up, I think a lot of that stuff, specifically like programming and stuff, that gets kind of covered when you're doing it. If you're going to work at a dealership, they're probably going to show you how to program their vehicles. Yeah,
exactly. Yeah.
Indie shop, it's just going to be a really rare case that you're coming out of school and, all right, you're our main diag person. Go get it.
Yeah, it just doesn't happen very often. So we toyed with that idea. This was pre-COVID when things moved a little smoother within the college. But we were talking with the other trade programs, because we're all kind of in the same, we're on the same campus, right? Where the campus is split into 2, East and West. We're on East. And so we're talking to HVAC and welding and auto body and facilities management. And we were talking about getting a, basic comprehension course for a student wanting to enter any of these programs that would work with basic hand tools and threaded fasteners. And each program wanted to inject something that pertained to them. And, maybe we could make that work. And we didn't actually make any headway on it in getting it to happen, but the talks were there. And so maybe someday we can get something like that going to try to get everybody to somewhat of a floor.
Yeah, it would have to come from us on our side of the classroom. The maybe not the techs, but the shops would have to really start demanding this and supporting it. Mm-hmm. And I don't know if that happens. Right now I think they're just crying for help. They'll take a warm body that can find the shop, every morning.
Right.
Well, dude, if we keep going, we won't have anything to talk about next time. Assuming you'll come back on.
Anytime. I'd be happy to.
Yeah, really enjoyed this.
For sure, man.
Yeah. Thank you again.
Hey, thank you.
Sean Tipping of the Automotive Diagnostic Podcast, community college instructor, mobile diagnostic and programming technician. Anything else? Any other?
Hockey player. We'll go with that.
Oh.
A very slow, uncoordinated hockey player, but nonetheless.
Well, I didn't know if you were like a stand-up comic or a screenwriter.
No, those wouldn't make me much money.
Yeah. Build decks on the side. Well, take care, man. Thank you so very much for this, and we'll talk to you later.
Thanks, Matt.
You've been listening to Matt Fonslow, diagnosing the aftermarket A to Z on the Aftermarket Radio Network. Follow Matt on your favorite listening app. He's very interested in what you have to say. Let him know what you'd like him to cover and come on the show. Matt is all for advancing the aftermarket. Find Matt Fonslow on social media and connect or on aftermarketradionetwork.com.